Hello class, this is a continuation on paying off loans, and in this video we'll be looking at the first method on paying off a loan. This method considers the loan as two different parts. Part A is the original value of the loan as a compounding interest investment, and Part B is the regular repayments is going to be considered as an annuity that we look to grow. And then when we take the part A and subtract it by part B at any given time n, that is the value of the loan at that time. So let's get straight to it. A $10,000 loan is charged 12% per annum, compounding monthly. If $250 is paid each month, how much is owing after? We're going to be doing three different calculations: 3 months, 1 year. And actually for this one, I think we're going to change it to n number of years. So an expression for any number of time, any number of years, or n values. First, we should always summarize the key values that we need. So our principal amount is $10,000. Our rate is 12% per annum, but it's monthly. So that will be 0.12 divided by 12, which is 0.01. Our regular payments, deductions, D for deductions, is $250. So let's get to it. So for 3 months, first what we do is we take the original value of the loan. So let's do this as the compound interest. A equals P bracket 1 plus R to the power of N. Just using the values that we have, that's 10,000, 1.01 to the power of, in this case, 3 or months. I'm just going to leave it as this value here. As for the annuity of the regular repayments, 3 months is small enough that we can just do all three. So here we go. Let's go the deduction 1. The first deduction is $250. In this one, we'll receive the interest 2 times, because they only make the first repayment after 1 month. The second deduction is $250, 1.01. That will receive 1 month of interest. And the last payment, well, they make the payment on the month it's charged, so this receives no extra interest. Okay, making this into a sum, the S of n, this becomes, going from the smallest to highest, 250 plus 250 1.01 plus 250 1.01 squared. Simplifying this becomes 250 outside of 1 plus 1.01 plus 1.01 squared. In case you didn't see how I factored that out, notice how each expression has 250 there, so I factored that out. Okay, and now from here we find this as an annuity. The sum of a geometric series. I'm sorry, where the first term, A, is 1, our rate is 1.01, and N is 3 different terms. Careful not to look at this value, because N is the number of terms. So that's 1 term, 2 terms, 3 terms. So N is 3. 1 outside of 1.01 to the power of 3 minus 1 all over R minus 1 in which case it's going to be 1.01 minus 1, and that there is the value we need to substitute. Putting the two together, it's going to be part A minus this sum. So the value of the loan after 3 months is this expression here. Let me just copy it to make it easy. Let's change the color there. For this, it's going to be minus the amount of interest this has gained. So 250. I can remove that 1 because it's just 1 times that amount. Let me actually just copy it again to make it easy for myself. Changing it to blue to match. And then this is what we're going to be typing in to our calculators. So after 3 months, the value of the loan will be 10,000. 1.01 to the power of 3 minus 250. 1.01 to the power of 3 minus 1 over 0.01. So at the end of 3 months, the value of the loan to the nearest whole dollar is 9545 point, and we should approximate this to the nearest whole dollar, $9545. So hope you saw how this method works. We break this down into 2 different parts. Let's do this one more time. For this, before we continue, we need to figure out what our n value is. Well, because it's in months and we have 1 year, n is 12. So that's 10,000, 1.01 to the power of 12, lots of interest. I'm going to leave it as that expression there. So here's the first deduction, the first payment. Okay, this one receives 1.01, that's the amount of interest. This first deduction will receive 11 months of payment. The second one will receive 1 less, 10 months of payment. This continues until the 11th month. 1.01 to the power of 1. So there'll be 1 month of interest for this deposit. And the last one, we just deposit 250 on that month, and that doesn't receive any interest. Skipping a few steps because we have the first one here. Obviously for this, you normally should do the full working. So S of n equals 250 outside of 1 plus 1.01 plus 1.01 squared plus all the way up until 1.01 to the power of 11. We can convert this again into the sum of a geometric sequence, or series, sorry. The first term is 1 outside of the rate to the power of the number of terms, 12, minus 1 all over 1.01 minus 1. I'm going to simplify that one to just 0.01. Oh, sorry. We should now just bring the two together. So now it's going to be the value of the loan at 12 months is this expression here, minus this expression here. And that's what we're going to be calculating in our calculator. $10,000, 1.01 to the power of 12 . So after 1 year, the loan still is owing $8,097.6245, and let's just round that off to approximately $8,098. Okay, so now let's make an expression for the n number of years for this. Well, for this one, because we have the pattern, we can see it now, the original $10,000 will receive 1.01 n number of times. The first payment is $250 to the power of n minus 1. It was always 1 less than this because it's 1 month after they make the first payment. The second payment, it's n minus 2. This keeps going until we get to the power of 1. Sorry, d2, that's d n minus 1. And d onto the last month, it's just the value of the 250. Summing all of this together, it became 250 outside of 1 plus 1.01 plus 1.01 to the power of 11. It was always 1 less, sorry, not 11, to the power of, I apologize, n minus 1. It's always 1 less than the length of the value we've been given. Making this into the sum of a geometric sequence. The first term is 1, so 1 outside of, the rate is 1.01 divided by the previous, so 1.01. It may look like n is the value that we're looking for, but because we have the extra term at the front, it's actually to the power of n minus 1 all over 0.01. And here altogether is the expression that we have for the n number of years. So a(n) is 10,000, 1.01 to the power of n minus 250, 1.01 to the power of n minus 1 all over 0.01. We can do this for any n value. Thanks for sticking for that long. Hope that gave you an insight into the two-part method where we broke it up into a compound interest formula and an annuity. Hope to see you in the next video. Best of luck.